Well, I've got another Magnavox ZV457MG9A. This one got shipped into me from Colorado. And take a look at the display on this one. It lights up with no problem. I don't have a light on the source at all. And it tells me there's a tape in there. Well, let's try to power it up and see what happens. Okay, I do get a light on the DVD. Can we switch it to VCR? Still thinks there's a tape in there, however. And then it powered off again. Power on. The fan does run. Once again, VCR. Still thinks there's a tape in there. And then it powers off completely. Power light goes off. So what's going on with this thing? This one's going to be a fun one, I think. Might just have an oxidized mode select switch. Kind of hard to say. But I'll get my overhead camera fired up. And maybe I'll try to advance the loading motor right here by hand just a little bit. And see if it can find its home parked position upon power up. Well, let's see what's going to happen. Well, I did manually advance the mechanism just a little bit by hand here. So I'm going to try to put it all the way down with no tape in it. When I power the unit up, it should try to eject it. The fan starts, the DVD tries to load, but I never get any VCR action whatsoever. And then the power shuts off and the fan stops. So I think before I go any further whatsoever, I'm going to go ahead and pull it apart and clean the mode select switch. That can cause some pretty interesting problems. Okay, now remember, to gain access to the bottom of the mechanism, there are two screws. One is plainly visible, the other one is hidden underneath this ribbon cable. And remember, they are two different types of screws, not to get them mixed up upon reassembly. This one is a machine thread, and this one is a coarse thread like a wood screw. It's meant for plastics. I'll show you a close-up when I get them out. Alright, there are the two screws. This screw on the right is the one that goes on the right side of the chassis. And as you can see, it's got a very fine machine thread. The screw on the left over here is the one that goes under the ribbon cable, and it has a very coarse thread. Don't get those two mixed up. Alright, now that I've got the mechanism completely out of the unit, I can go ahead and tip it up, and then very, very gently lift up right here. Usually what I'll do is I'll just stick my hand under here to prop it up just a little bit. And so that way I can see the mode select switch. I'll just reach in here and pop the top off. Just like that. So there is the mode select switch. It definitely has seen better days. We'll go ahead and hit it with the stainless toothbrush. Now, a customer said they only had a brass toothbrush. That's perfectly acceptable. Anything that's going to just basically scuff up those silver plated contacts to make good contact once again. So whatever you have, even a fiberglass eraser would work perfectly fine. Whatever you have at your disposal, I just happen to have a stainless toothbrush, so that is what I use. Alright, so I'm pretty happy with that. We'll go ahead and hit it with a little bit of acetone. Then we'll apply some dielectric grease. Let me go ahead and clean off the movable portion, the wipers first. All right, that should be good. Keep in mind, you only want to scrub in one direction. So as this faces you right now, you only want to scrub from left to right. If you try to go the other way, it's going to bend those little tabs up and out of the way. Once you bend them, there's really no going back. So I just want to go ahead and wipe them off with a bit of acetone. Once again, one direction only. I can see the silver tips bright and shiny. That's what I want to see. Next, I'll do the same thing with the mode select switch, the stationary portion. Remember, acetone will not eat these mode select switches used in these Funai symphonic units. So you don't need to worry about it eating the plastic away. It will eat the Samsung mode select switches used in the Sonys, however, so you do have to be very careful when doing a Samsung or a Sony VCR mechanism. All right, there it is, all done. Next, I'll go ahead and apply some silicone dielectric grease to the stationary portion and to the movable portion. I just want to make sure no air is exposed to those silver-plated contacts any longer, just like that. And I'm going to put a nice glob on that. I'll put the switch together. I'll run it around multiple times, probably 20, 30, 40 times, just to distribute that grease evenly. Then I'll put it back together and see what happens. I think I'm just going to loosely assemble this thing on the bench before I put it back in the frame and see if it makes any difference. Now to put the two halves together, just line them up, press down, and it snaps together. Run it around in both directions multiple times. When you get it done, you can open up the switch and you should see the track marks. Make sure you line up the switch and then go ahead and put the two halves back together. Just remember, the point on the mode select switch has to go into that hole right there, just to the left of the shaft. Those two must engage. There's no other way it can go together, otherwise you will break the mode select switch. Okay, well, good news. If I power the unit on, it does power up and it does stay on. It does not try to shut off any longer. And it no longer shows that there is a tape in the unit. So I do believe the mode select switch was causing a problem. However, if I try to put a tape in it, it does not ever try to take the tape, and now it will power down after a few seconds because it knows that there is a problem. So I need to go ahead and pull a schematic on the capstan motor drive, which is what drives the loading motor and the cylinder motor, as well as the power supply, and make sure everything that should be there is actually there. So here is a schematic that shows the capstan motor connection to the main board. So I'm interested in pin 1, the always 12 volts, pin 2, the power on 5 volts, and pin 11, the always 12 volts again, and pin 12, the always 18 volts. So let's power the unit on and see if we have the powers that we need, and I'm going to check pin 6 to make sure we have a good ground, as well as pin 10. Alright, so here is pin 1, and we do have 12 volts. Pin 2 should have 5 volts, and I've got nothing. That's a problem. So pin 11 should have 12 volts once again, and I have 12. Should have 18. I've got 17.77. So going to ohms, I want to go ahead and check pin 6. I've got 0.6 ohms, and pin 10, and I've got 0.5 ohms. Perfectly fine. So I need to find out, where does the power on 5 volts on pin 2 actually come from? That's the problem. We're missing the power on 5 volts. Let's go ahead and check it one more time just to make sure I'm not going crazy here. So I'm on the pad for pin 2. Power on. The red LED is illuminated and I have 0.012 volts. That's an issue. Back to pin 1, I should have 12 volts. And back to pin 11, I should have 12 volts. Back to pin 12, I should have 18 volts. Everything's there. We're just missing the power on 5 volt supply. So I'm going to try to find out where that comes from, and we'll move on from there. So before I go too terribly far, because I have 0 volts on this line, I'm just going to go ahead and do an ohm check to ground. I shouldn't see more than a few hundred ohms to ground. So pin 2, I see 1 ohm to ground. That is a problem. Right off the bat, I'll show you what I suspect. So here is pin 2, the power on 5 volts. Look where it goes. comes right down to here, and it goes into C1544, a 220 microfarad 6.3 volt capacitor. That's my prime suspect right there. So check out what I see right here, C1544. Let's measure from the negative side to ground, 0.5 ohms, and the positive side to ground, 0.8 ohms. I'm going to go ahead and zip that off the board real quick, just unsolder one lead and see if we get a change in resistance. Okay, I have the one lead unsoldered, so I'm going to go ahead and probe this pad right here, which is connected to the same pad, and now I see 234 ohms. But watch this. If I probe the lead, 0.7. That capacitor is a dead short. That's the problem. Now, it might have done some other damage. I need to look at the schematic and see if there's anything else, like a switching transistor in that line, because if there is, chances are it damaged that transistor as well. Alright, so here is where the 5 volts comes from. Q1057. The collector should have 11.2. The base should have 5.8, just through a simple resistor divider network, and the emitter should have 5.1. Let's measure those voltages. Here is the transistor. Here is the collector. Here is the base. And this is the emitter. That's our problem. We need to change that transistor. Okay, here we go. New transistor installed. Collector voltage 11.1, base voltage 5.7, and emitter voltage 5.1. New capacitor installed, 5.1 volts. So now let's measure the voltages on the pins once again. We should have 12. We should have 5. Then back over here we should have 12 and 18, and we do. Let's flip the unit back over now and see if it accepts a tape. Okay, here we go. Power on. Let's see if it's going to take a tape. It loaded the tape. Absolutely perfect. Hit play. And it plays. Let's make sure fast forward and rewind work okay. Stop. Fast forward. Stop. Rewind. And make sure it gives the tape back correctly without eating it. Absolutely perfect. So next, I'll go ahead and put it back in the chassis. I'll hook up a monitor, make sure it has video. So I went ahead and did a quick ESR of the power supply capacitors, and all of the capacitors that I've ever had problems with have been replaced on this unit. So it looks like it's an upgraded model. They used higher quality capacitors possibly. I'm not sure. They're still 85 degrees Celsius, but like that main 4700 microfarad capacitor checks less than 0.1 ohms, so that's excellent. So I'm not going to do any work on this power supply. I'm just going to go ahead and put it back together and ship it back the way it is. Alright, well I've got it all back together. It's playing. I do have a monitor connected to it right now, although it's not in my video capture device. The DVD actually does play. I did find 7 out of 18 capacitors out of my qualification for being intolerance. The DVD actually does play just fine. The VCR is working perfectly. I'm going to go ahead and contact my customer and see if he wants to replace the 7 bad capacitors or replace all 18 capacitors. I'm going to leave it totally up to him, or change none of them. He may not even be interested in the DVD player whatsoever. He may only want to play VHS tapes. So I spoke with the customer and he decided to go ahead and change all 18 capacitors on this board to make this unit reliable once again. Alright, so here is a roadmap that I've made. Always make a roadmap that shows the polarity of the capacitors and the value. Now this number down here is the ESR result that I got when I ESR'd all of these capacitors. 5.4, 0.25, 3.3, 0.55, and so on. And so the ones I have circled in red are the ones that exceeded my qualification for being intolerance. But like I said, the customer has opted to go ahead and replace all of the capacitors. So I'm just going to go ahead and zip them off the board. I'll use the twist off method and then clean off the pads. Now the new replacement capacitors that I'm going to be installing on this board are the standard radial leaded electrolytics. So a lot of these I'll have to bend over to put on the board. You've seen me do it before, but I'll do a real quick, maybe a time lapse of me getting the capacitors off of the board. And so once I have them all off the board and the leads are broken off, we'll go ahead and ESR them. I'm going to try to put numbers on each one so that we can compare the new to the old off of the board, because I can't really unsolder one lead of these capacitors effectively off of the board like I do with the standard, like a power supply, where you've seen me unsolder one lead. So I have a suspicion that a lot of these are probably in parallel with other capacitors, so they may actually test way worse out of circuit than they do in circuit. So I'll go ahead and try to number all these, get them off the board, we'll do an ESR check and see if the results are close to what we have here. All the caps have been changed. Let's go ahead and check the suspect capacitors out of circuit now and see what they test like. First, we'll check this 47 at 6.3. Previously, it was 3.3 ohms. Out of circuit, 4.2. Next, the 47 at 6.3. Previously, it was 5.4 ohms. Out of circuit, 7.2. Onto the 330 at 6.3. Previously, 0.59 ohms. Out of circuit, 90 ohms. Onto the 47 at 6.3, previously 4.8 ohms in circuit. Out of circuit, 5.0. Next, 100 at 6 volts, previously 2.9 ohms. Out of circuit, 3.0 is the lowest I've seen. 47 at 6.3, and it reads 6.1 ohms. Previously, it was 3.5. Lastly, a 47 at 6.3, previously 5.2 ohms, now 10 ohms out of circuit. So you can see the importance of checking these things out of circuit versus in circuit. Anyhow, all the capacitors have been replaced. You may notice some of them I stood up straight because there's enough clearance from this line on. I made this mark on the circuit board. So anything to the right of this line right here, there's plenty of clearance. Anything to the left, they have to be laid down. There's only about 10 millimeters of clearance in this area. So all of these I went ahead and stood up again. All of these I went ahead and laid down. Let's go ahead and put it together and give it a final test. I'll go ahead and do a quick optical pickup cleaning as well as a VCR transport cleaning. You've seen me do that 1,000 times, so I don't think I need to record that. On the off chance that you're curious about the new capacitors, I'll recheck the 7 that tested bad, and I'll read out the previous and current reading. So previously, this capacitor measured 3.3 ohms. The new capacitor 0.59. This one was 5.4 ohms, currently 1.9. This one was 4.8 ohms, currently 2 ohms. This one was 2.9, currently 0.68. This one was 3.5 ohms, currently 1.6. And last, this one was 5.2 ohms, currently 1.8. So you can see the difference of replacing the capacitors new versus old. And I think I missed one capacitor. Previously, this one, it's a 330 at 6.3, was 0.59 ohms, currently 0.22 ohms. Okay, so I've got it all back together, ready to go. I'm going to go ahead and make sure the time is correct on it. And that is correct. April 14th, 2021, 9:37 p.m. I do have a VHS tape in it right now. I'm going to go ahead and put a blank DVD-R in it, let it load it. And I'm going to make sure it's on the 3-hour mode because my VHS tape is a compilation of SP and EP recordings, and it is 2 hours and 55 minutes long. And it loaded it up. It knows it's a -R, so I'm going to hit the record mode, and it tells me I'm in the LP 3-hour mode. So next, I'm just going to go ahead and hit the dubbing VHS to DVD. Let me make sure I have that in the menu correctly. We'll go down to recording. Auto chapter let's change it to every 5 minutes. Auto finalize when the disc is full. We may have to manually finalize because it's going to be 5 minutes short. And the dubbing mode is VCR to DVD. Make recording compatible on. Well, that's it. Let's go ahead and hit the dubbing button and see what's going to happen. VCR to DVD dubbing. Here we go. Well, we'll check back in about 3 hours and we'll see if we get the same copy on the DVD. Okay, well, I got the 3 hours recorded on the disc. I do not believe the disc is finalized. I ejected the disc. I'm going to go ahead and reclose it and see if it can read the table of contents, and then we'll try to finalize the disc. Okay, so it does have the title. Let's go ahead and try to press play, see if it plays the disc at all. It is playing. Try to skip a couple of chapters. Hit stop by mistake. And it does appear that it is playing. So I'm going to stop it. I'm going to turn the resume off. I'm going to go to setup. And I'm going to go to disk edit. And finalize disk. Yes. Well, that seems to be it. It did finalize the disk. Let's go ahead and stop it. Go into setup one more time. Now the disk edit is blank. I cannot do anything else with the disk. Well, that's it. It's up and running. The Magnavox ZV457MG9A replaced all the capacitors on the DVD recorder board, made a DVD test, playing back right now, absolutely perfect. Repaired the power supply for the Capstan motor, the 5 volts was missing. Troubleshot and replaced that shorted capacitor and the open transistor. That's the end of the video. I really appreciate you watching this video. Go ahead and leave me a question, a comment, a concern down below. I try to read all the comments and respond when I have time. While you're down there, hit that subscribe button and like this video. It really does help my channel grow. You can follow me on social media, Facebook, Instagram, Twitter, at NorCal715. You can email me, NorCal715videos@gmail.com. Remember, with your help, we can try to keep these things out of the landfill, out of the recycle bin, and out of the e-waste facility. Everybody, thank you so much once again for making it to the end of this video. I really do appreciate it. Everyone have a great day. Once again, thank you so much for watching. Bye-bye.